So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in a billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Movile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in a billion years. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo, there's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window. Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, The waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
A team of intrepid scientists have devised an audacious plan to unravel the mysteries of the universe. Their secret weapon? Computation. The very heartbeat of living systems. But what's that? And how will computational zones help us to find extraterrestrial life? Let's find out. In our universe, there are special places called habitable zones. They hold the key to life as we know it. You see, planets are a bit like picky eaters. They have specific preferences for their conditions. Just as we humans need things to survive, planets need their environments to be just right for life to thrive. So, what's the secret recipe for a habitable zone, you ask? It's all about finding that sweet spot where liquid water can exist. Water, as we know, is the magical elixir of life. Planets love to have it flowing or sloshing around on their surfaces. So, we need to find the perfect balance. If a planet is too close to its star, things get toasty, and water evaporates into a sizzling mist. On the flip side, if a planet is too far away, it becomes an icy wasteland, freezing water solid and turning potential life into popsicles. But within that perfect middle zone, also called the Goldilocks zone, temperatures are just right. That means planets have the perfect conditions for life to potentially take root. For a long time, scientists have been looking for planets in these zones. And as of January 2023, we have found a total of 63 potentially habitable exoplanets. However, a recent study has changed our view of where we should look for life. Gone are the days of restricting our search to mere habitable zones. Oh no, we're thinking big. Get ready for the computational zones. These enchanting realms could house life forms we've never even dreamed of encountering before, But what exactly are these computational zones? Well, let's see. When scientists search for life in the universe, they usually look for things similar to what we have here on Earth. They imagine creatures living on a planet's surface at just the right distance from their star and using water for important chemical reactions. But what if life can be much more diverse and fascinating than that? Imagine life using different liquids instead of water. Picture life hiding deep underground in icy moons. It's even possible that life doesn't need a star at all. And there might be biological systems that are different from our idea of life in general, but still alive in their own unique way. That's why two clever researchers have come up with a new idea. They want to change how we think about the places where life could exist. Instead of focusing on habitable zones, they suggest looking for computational zones. Think of these computational zones as special kitchens, where the secret recipe for life is being prepared. To make this recipe work, we need three key things. First, we need a variety of special ingredients, like different chemicals. Just like a chef needs various spices and flavors to create a delicious dish, life needs different chemicals for its calculations. Second, we need a source of energy, like sunlight or heat from hydrothermal vents. This energy powers the cooking process, just like heat powers a chef's stove. Lastly, we need a dedicated space, like a kitchen counter, where all the calculations can happen. It's the place where the ingredients come together and amazing things start to occur. In our case, it was our solar system and our planet Earth. Basically, computational zones should have three things: some chemicals, source of energy, and space. This makes a pretty wide sample, isn't it? By focusing on computational zones, the researchers believe we have a better chance of finding signs of life. These zones could lead us to amazing discoveries and show us that life in the universe is much more creative and diverse than we ever imagined. And here's the real mind-boggler. This idea also leads us to think about technology. Yes, AI and stuff. Just as we humans create and use technology, could life itself create its own technological marvels? Life could be biological, digital, or even something completely different. Computational zones give us a fresh way of thinking outside the box and get creative. Now here's another twist in all this research. Turns out that life might be much closer than we think, as if in our own solar system. It turns out that the insides of icy moons, like Europa or Enceladus, answer to all these conditions. They're just as fascinating as the surface of rocky planets. It's like realizing that hidden treasure lies right beneath our feet. Europa is Jupiter's icy moon, which is as old as our Earth. It looks like a half-sphere with a bright icy appearance, an off-white color with a hint of blue. Mysterious dark lines stretch across the moon, forming patterns. It lacks towering mountains or deep basins, but instead showcases dark ridges, grooves, and long streaks. As you move toward the bottom of the image, Europa fades into darkness, leaving us curious about what lies beyond. But the most important thing about Europa is that it's a fascinating candidate for life. First of all, this moon has liquid water in abundance. Scientists believe that there might be an entire salty ocean beneath its icy surface. There might be twice as much water as all the oceans on Earth combined, but life needs more than just water to exist. It requires certain chemical elements like carbon, hydrogen, oxygen, and so on. They're like the building blocks of life. These elements are found throughout the universe and make up a whopping 98% of living matter on Earth. And Europa is believed to have a lot of all these elements too. Perhaps they were brought there in the distant past after a collision with asteroids and comets. Although it's pretty cool that we found organic molecules on Europa, it doesn't automatically mean they are linked to life. These molecules can be created in non-living processes as well, but they still give us some very important clues. And finally, energy. It's like fuel for life. Just like we need food to keep going, all living things need energy to survive. On Earth, plants get their energy from the sun through a cool process called photosynthesis. Plants turn sunlight into food, and when animals eat those plants, they get energy too. But the kind of life that might live on Europa can't rely on sunlight. Europa is covered in a thick layer of ice, so there's no sunshine reaching its surface. Instead, life on Europa would have to find another way to get energy. And that way is through chemical reactions. Europa's surface gets showered by radiation from Jupiter, which is not so great for living things up there, to say the least. However, this radiation can actually be helpful. It helps to create oxygen and hydrogen in Europa's atmosphere. But that's not all. As Europa orbits around Jupiter, it gets flexed and squeezed by the planet's gravity. This flexing generates heat, just like how bending a paperclip can make it warm. The heat from this process can provide energy for life too. So as you can see, Europa's potential life forms have to get creative. But this little moon still has a very high chance of supporting life. It's a fascinating and mysterious world out there. And Saturn's moon Enceladus is also an exciting place where life could thrive. But detecting this life is no easy task. The moon is covered by a thick ice shell with a super deep ocean beneath. Even here on Earth, that would be a huge challenge, let alone on a moon halfway across the solar system. Enceladus is nothing like Earth, so don't expect to find cows and butterflies there. But it would have its own unique ecosystem. Some organisms that rely on chemical reactions for energy, although life on Enceladus, if it exists, might be extremely scarce. But regardless, we should keep exploring it. Any findings would be helpful for our future missions. All these new discoveries open new possibilities and fuel our curiosity about life beyond our planet. Who knows what exciting discoveries await us in the vast universe? Let's keep exploring and find out.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets, by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet, and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot 4-inch-wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal, with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury's the closest planet to the Sun, Venus is still the hottest one. Life on Venus? More like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
You fly away from Earth at a safe distance in your super modern spaceship, and then bam! You travel faster than the speed of light in interstellar space. How cool! The light from thousands of stars rushes past you. A few minutes, and you're on the other side of the Milky Way and going to work. Such travel has long been common for humans, for you are a member of the human civilization that has conquered the entire galaxy. But it took almost 90 million years to get there. So how did we achieve this? It's like a computer game. In the beginning, we had a fleet of 3 motherships that could travel at 310 miles per second. Each of them had 10 colonization pads. The ship could undock a pad and drop it on the desired planet. We also had 2 speed ships that traveled twice as fast but could only colonize one planet. Each colonized planet could send one new ship on an expedition. So humanity was able to spread across the galaxy in 90 million years. Most of that time was spent flying from star to star. So the main problem of colonization is speed. Year 2021. Our spaceships can now fly at about 24,850 miles per hour. That's enough speed to travel from New York to Los Angeles in less than 4 minutes. But a trip to neighboring planets like Mars still takes about 7 months. The nearest star to the Sun, Proxima Centauri, is 4.2 light-years away. That means light, the fastest thing in the universe, takes 4.2 years to get there from the Sun. It would take our rocket 73,000 years to get there. That's longer than an advanced human civilization has existed. And our galaxy, the Milky Way, is 105,000 light-years wide. So even traveling at the speed of light would take forever. So, naturally, humanity came up with other ways to travel. Let's move into the future and imagine that we've solved this problem. We started accelerating with microscopic probes propelled by a directional laser beam from Earth. This made it possible to reach speeds of 25% of the speed of light, still very slow. The problem was that nothing that has mass can travel at the speed of light. So we moved on to the Alcubierre drive study. This method doesn't involve moving from point A to point B, but instead compressing the space between those points. Here's a piece of checkered paper. Imagine that you need to travel 3 squares to your destination. Instead of moving in a straight line as fast as possible, we squeeze these squares so that our spaceship is at point B. Now we unsqueeze them back. Space is normalized and we've traveled, in fact, standing still. This is how the Alcubierre drive works. It compresses space in front of the spaceship and expands it behind its tail. So, theoretically, an Alcubierre drive spaceship can move at any speed, even faster than the speed of light. But the amount of energy needed to do this is enormous, and it could be compared to the mass energy of the entire planet of Jupiter. So, while some scientists were working to improve the Alcubierre drive, others were looking inside the most mysterious object in the universe, a black hole. A black hole is something so heavy that it attracts even light and won't let it go. Imagine a circular trampoline. This is our space-time. We put a basketball in its center. The trampoline sags a little bit. Now all the objects we put on the trampoline will roll toward the basketball. That's how gravity works. But if you roll the golf ball past the basketball, it has a chance of getting out of this funnel. Now put a heavy bowling ball in the center of the trampoline. The trampoline sags even more. Now the golf ball will inevitably fall into the funnel with the bowling ball with no chance of escape. That's how a black hole works. And some scientists believe there may be a wormhole at the heart of a black hole. It's a shortcut between point A and point B in the universe. Back to our piece of paper. Instead of moving straight ahead, we fold the piece so that point A is right above point B. Now we make a hole in the paper and move to point B. We unfold it back and voila! You've arrived at your destination. So there's a theory that if a spaceship enters the black hole's gravitational field and withstands the incredible stress there, it can exit to any other point in the universe which that wormhole led to. It might even be another galaxy, or even a parallel universe. Well, our research was successful, and now, looking at a map of the Milky Way, we can get to absolutely anywhere. All that remains is to choose the right place to colonize. There are about 1 billion stars. Around each of them are planets possibly suitable for life. So we need to narrow down the list. First, we look for relatively young stars, almost like our Sun. Near them, a human colony can potentially live for a long time. After that, when a star gets old, it begins to expand and turn red. In the last stages of its life, it can absorb all the planets around it and then explode with such force that the light from the explosion can be seen dozens of light years away. Secondly, the candidate for a human colony must be in the habitable zone of the star. It's a sweet spot, not too far away from and not too close to the star, so that it's not too cold or too hot there. In other words, water on the planet must exist in liquid form. Also, the candidate planet must have a solid surface so that we can live on it. Another important factor is the size of the planet. If it's too big, its gravitational force will press on us. It'll be harder for us to jump, walk, and lift weights on this planet because we're used to the Earth's gravity. But if the planet is too small, we'll feel like real strongmen there. We'll be able to jump high and lift large weights. But then our muscles will lose tone and our health will deteriorate. So, we're looking for a planet about the size of Earth. Altogether, we have about 100,000 star systems that fit our parameters, so we start exploring and colonizing. And here's our first target. We've named this planet New Home. Clever. We fire up our faster-than-light engine, and bam, we're there. Even though this planet fits all our criteria, it's still hard to call this place home. Desert landscapes with lots of craters and canyons. We'll have to work hard to make this place look like Earth. The terraforming phase of the planet is about to begin. That means we're going to change the climate and the atmosphere here. We need about 78% nitrogen and 21% oxygen so we can breathe here without spacesuits. So we're launching air plants. Other plants will produce water. We're also building power plants and a plant to produce fuel for our spacecraft. Last but not least, food extraction. Once everything is ready, the colony here can exist on its own. And after several centuries, this planet will be developed and populated enough to send an expedition to colonize neighboring worlds. So, for many millions of years, humanity has been weaving its web in the Milky Way. From one planet to another, we've colonized our galaxy. Humanity is now not only multiplanetary, but also interstellar. The next goal is to make us an intergalactic species.
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede. And it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. it will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly. Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us. Or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, Scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth. Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's fifth biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the fourth planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of two exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these two Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these two new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys Were Us, Wolfie and her mama will all be out there waiting for us.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculus telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP890-9b. It takes about 3 days to complete 1 lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9c. This one was discovered by the Speculus telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found 2 Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but you know. And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great. Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited.